Have you ever wondered what are you made of? Well, the answer is that you are made of leftover of the Big Bang and stardust. Well, you, me and everybody and everything else. But let's start for the beginning. For the very beginning, in the Big Bang, scientists believe that the universe that we know started with a big explosion around 13.8 billion years ago, or 13,800 million years if we use the European format. Before the Big Bang, we don't know, around 13.8 billion years ago, the universe was concentrated in a single point that exploded. That explosion is what we know as a Big Bang. At those earlier stages, radiation and heat were intense. It took around 380,000 years for the universe to cool down enough to form the first and more simple elements, hydrogen and helium. Hydrogen is part of the water in our bodies. Helium does not have a role in our bodies, so we don't have it, at least in an amount that we can detect. But it is the gas that we use for parties, balloons, and if you inhale it gives you a funny voice. At that point, scientists believe that the universe was a dark place, as there were no stars. It took around 400 million years to form the first stars. How are stars formed? Well, due to gravity forces, the leftovers of the Big Bang started to gather together in nebulae and start to condense. Over time there were some areas where the amount of material gathered in started to heat up and started nuclear fusion of the hydrogen. Before continuing, let's explain nuclear fusion. I will explain as simply as I can. We will start with the structure of the simplest atom, the atom of hydrogen. This atom is formed by a nucleus with a proton and electron. The proton forms the nucleus. The electron orbits around the nucleus. When the heat is high enough, the atom loses the electron and the nucleus is left as a proton moving around. Protons have a positive charge, so when two of them collide, they repel each other and continue moving around. However, when the temperature is high enough, the repulsion force is not strong enough and the protons merge, creating a nucleus of helium and releasing energy. The helium created is a new element. This process of joining atomic nuclei is known as nuclear fusion. Yes, I know, a stable atom of helium has 2 protons and 2 neutrons and it will require 4 protons for its formation, but I just want to keep it simple. Let's go back to our star. It is starting to generate energy due to the nuclear fusion of hydrogen. By the way, the light that we see from the stars is due to this nuclear fusion. This is the process that have been taking place in the Sun for the last 4.6 billion and it is estimated that it will continue for around 5.4 billion years more. Eventually, the star will run out of hydrogen. What will happen then? It will depend on the size of the star. Smaller stars, up to about 7 times the mass of the Sun, will form what is called a red giant. Meanwhile, bigger stars will form red supergiant. Let's start with the smaller stars with up to about 7 times the mass of the Sun. When the hydrogen is consumed, the gravity force will shrink the core of the star, increasing the pressure and temperature in its core. As the pressure and temperature increase, helium will now be used to produce carbon via nuclear fusion. While the core collapses, the outer layers of material in the star expand and form what is called a red giant. The new element formed now, the carbon, is the basic building block to form proteins, carbohydrates, and fats in our body. Are you wondering what will happen when the helium at the start is consumed? The core will collapse once again and the outer layer will be ejected as ionized gas into space. The core will cool and shrink over time, forming a small, hot ball called a white dwarf. The white dwarf radiates its remaining heat into space for many billions of years and at the end, it will cool down to sit in space as a cold dark mass called a black dwarf. Let's see what happens to stars with more than 7 times the mass of the Sun. They will follow similar steps to the medium mass stars but form what are called red supergiants. Since the core has more mass, it will become hot and dense enough to produce heavier elements via nuclear fusion. The nuclear fusion will stop in iron. The reason is simple. Nuclear fusion of iron requires more energy than the energy produced in the reaction and it is not sustainable for the star. As I want to keep it simple, I will not go into details about the elements formed in this phase. I will just mention that it will form, among others, oxygen and iron. Oxygen is what we breathe. It also forms water when combined with hydrogen. Iron is the element that made red the blood, and it is a key component for hemoglobin. At this point, I guess that you are wondering what will happen to our red supergiant. With the core full of iron, the nuclear fusion stops, the core suddenly collapses, producing a supernova and expelling the outer layers into space. But that is not all. Depending on the size of the remaining core, the end will be different. If the left core is about 1.4 to 5 times the mass of the Sun, it will collapse into a neutron star, that we might be able to detect them as a pulsar. If it is heavier than 5 times of mass of the Sun, it will collapse into a black hole. I hope that you have found interesting this video. If you are interested in seeing a bit more detail and where I got the information, check the link in the description. It will help me to produce more videos if you leave a comment and or press like.